Hello everyone. In this video, we will cover select and ultimate survival models. For different genders, different racial groups, and different countries, the mortality rates are not the same. Therefore, separate life tables are being constructed for each of these groups. Another influence on survival is provided by underwriting. Any individuals who want to purchase insurance may need to provide a history of their health records and have a medical examination as requested by the insurance company. And healthy persons are more likely to be accepted as new policy holders. Consequently, it is reasonable to infer that individuals selected for insurance has a lower mortality probability than the original population of individuals at the same age. At least, this probability is lower for a few years following the issuance of the policy. And this period is called the select period. From that, we have the following modeling assumptions. Survival depends on the current age of a person and the age X at selection, the age the individual purchased the insurance. After a fixed number of years D, the survival advantage of recent selection wears off, and the survival probability is the same as it is for all insured individuals of that same age. And this D is the duration of the select period. Let's take a look at an illustration. A person at age X, the probability of survival within this year, reaching age X plus 1 is Px. And then we have the survival probability, Px plus 1, reaching the age X plus 2, and so on. Consider an individual selected at age X with a select period D years. At age X, the individual is selected, purchased the policy. We express this age with a square bracket. An individual select at age X. And then the survival probability, okay, reaching age X plus 1 is denoted by Px, where X is a square bracket. Usually the Px, the selected age, this probability should be higher than the one for the non-select age, Px. And then reaching the age X plus 1, here the notation is the square bracket X, and then plus 1. The survival probability in this year is P bracket X plus 1, reaching the age X plus 2, and select at age X. So we have the square bracket X and then plus 2. Until the end of the select period, we still have the square bracket along with the age X. After the select period, this is called the ultimate period. After the select period, the survival probabilities will be the same as other individuals of the same age. That is, the Px plus D at select age X, this equals simply Px plus D, the original probability, which is the ultimate probability of all the individuals of the same age after the select period. And then the same here. This is called the ultimate period of the model because the survival or the mortality probabilities now equals to an ultimate set of probabilities for other people of this age. Let's take a look at an illustration. Consider a select period of 3 years. at age 50, if an individual is selected at age 50, then we have P with a square bracket 50, and the corresponding mortality probability Q50. Q50 with the square bracket is 1 minus P of this age. And if a person is selected at age 51, then this person at age 50, the probability here is P50 without the square bracket, because this person is not yet selected. And then at age 51, the person selected at age 50 is notated as square bracket 50 plus 1, and the corresponding survival probability is this P square bracket 50 and then plus 1. The corresponding mortality probability Q50 plus 1 is this. And then for the individual select at age 51, okay, entering into the select period at age 51, therefore, the probability is expressed as P square bracket 51. And P50 with a square bracket plus 1 and P square bracket 51 are not the same. And here we have the corresponding Q51. At age 52, the notation here is P square bracket 50 plus 2. And then for the person selected at age 51, this is the first year of the select period, so P square bracket 51 plus 1. And these two probability are not the same. And P square bracket 51 plus 1 is not the same as P52 with the square bracket. All right, P50 plus 2 here corresponds to a person selected at age 50 and now reaching age 52. And then the P here corresponds to a person selected at age 51 and now at age 52. The P with a square bracket 52 corresponds to an individual selected at age 52. And all these three probabilities are not the same. All right, at age 53, the individuals select at age 50. This is already the end of the select period. So we no longer have the square bracket 50 plus 3 here. This becomes the ultimate probability, P53. And therefore, we have Q53 equals 1 minus P53 here. And then for the person select at age 51, this is still within the select period of 3 years. So we have P square bracket 51 plus 2. And this year, this is the end of the select period. After that is the ultimate period. And therefore, for age 54 and 55 here, we simply have the normal notation, P54 and P55 without any square bracket. And then here, same for the ultimate period. All right, let's consider individuals at age 50. The mortality probability is simply Q50. And if any individual select at age 50 that is meeting the selection criteria, they should have better health than the general population. And the selection here is Q square bracket 50. And we have the relationship. The Q with the selected population should be less than the Q with the standard or ultimate population. And then with this select group at age 50, 1 year later, this group of individuals reach age 51. The corresponding mortality probability is Q square bracket 50 plus 1. And then this group of people, this group of individuals already select at age 50. If they are asked to do the medical exam again at age 51, some may not meet the selection criteria. And therefore, the select mortality probability at age 51, which is Q square bracket 51, should be smaller than the mortality probability for individual at age 51 who is select at age 50. That is, normally Q square bracket 51 is less than Q and then square bracket 50 plus 1. The further away from the time of the selection, the less will be the effect of the selection. Here, all individuals are at age 50, but it's selected at different age. All right, that's it for the introduction of the select and ultimate survival models, and then we can do some calculation. All the probability relationships, including the life table functions, like here the TPX and 3PX, the calculation remains unchanged, even we work with the select and ultimate mortalities. But we need to keep 2 points in mind. The first one, be consistent with the age of the selection. The square bracket X cannot directly link it with the square bracket X plus 1. That is, an individual select at age X cannot be select again at age X plus 1. And then the second point, return to ultimate probability when the selection is over. That is, an individual select at age X, k years later, the square bracket X plus K is simply equals X plus K if K is greater than or equal to D. All right, let's take a look at an illustration. For an individual age 41 who was selected at age 40, and assume that the survival model has a select period of 3 years. In terms of the age notation, at age 40, this individual is selected at age 40. So we have square bracket 40, and then at age 41, square bracket 40, and then plus 1. Until reaching age 43, this is the ultimate period, or after the select period of the 3 years duration, then this becomes the long bracket one, the ultimate one, so simply 43. This is the age notation. All right, so for an individual age 41, select at age 40. So we have this age notation. Suppose we want to get the probability that this life survives to age 45. So we want to get this probability, 4p40 select age plus 1. Okay, suppose we are given these two probabilities, p40 plus 1 and 3p40 plus 2. Then multiply them together, we get the desired result. p40 plus 1 here is a single probability. Okay, no problem. And then the second one, 3p40 plus 2 can be further factored into, say, p square bracket 40 plus 2, p square bracket 40 plus 3 times p square bracket 40 plus 4. Okay, but the p's with the plus 3 and plus 4 are after the select period. This should be the ultimate probability, and therefore we don't need the square bracket for these two probability and write it as p43 and p44. Suppose we are given a life table function. This probability can be calculated as, say, like L40 plus 5 over L40 plus 1, select at age 40. And then the numerator L40 plus 5 is after the select period. Then we write it again as L45. All right, let's take a look at more illustration. Okay, suppose the select period is 4 years. Consider a life select at age 30. Calculate the probability that this life will die between ages 32 and 37. One way of doing it, okay, express this as 2 bar 5Q30, select at age 30, square bracket 30. We can compute the probability as this, 2P30 minus 7P30. As a product, this can be written as 2P30 times 5Q30 plus 2. The select period is 4 years. So 2 years later here, reaching age 32 is still within the select period. So we write it as Q30 square bracket plus 2. In terms of the life table function, this can be written as L32 minus L37 over L30. And L32 is within the select period. We write it as L square bracket 30 plus 2. And then reaching age 37, which is beyond the select period. So this should be the ultimate numbers of the ultimate period. So we write it as L37. Consider another case. A life currently at age 30, the life is select at age 29. Calculate the probability that this life will die between ages 32 and 37. The notation, 2 bar 5 Q30, but this 30, we must express this as a select age 29 and then plus what? This equals 2P30. Okay, this 30 expressed as, again, select age 29 plus 1, and then minus 7P, and then square bracket 29 plus 1. Similarly, as a product, we can write it as 2P29 plus 1, that is 2P30, and then times 5Q32. H32 is still within the select period, so we write it as the select H29 and then plus 3. In terms of the life table function, we get this expression. The next case, again, the life currently at age 30, but this life is select at age 27. The probability that this life will die between ages 32 and 37. 3 years has passed from age 27 to age 30. The notation 2 bar 5Q30, this 30 is expressed as the select life, select age 27, and then plus 3. All right, this expression, the age 27 plus 3, that is age 30, is still within the select period. So we write it as the select age 27 and then plus 3. As a product, we can get it as 2P30 times 5Q32. Reaching age 32, this is beyond the select period. The select period is only 4 years. Therefore, reaching age 32, this corresponds to the ultimate part of the model. So we use the ultimate mortality probability, simply 5Q32. In terms of the L's, at age 32 and age 37, these two ages are beyond the select period. So we use the numbers in the ultimate table. So L32 minus L37, the denominator, the age 30 within the select period. So we have L27, the select age, and then plus 3. All right, so you can get a more understanding on the select and ultimate survival models. In the next video, we will go through some calculation. Thank you and see you in the next video.